So hi, I'm Siddharth and in this short talk, I'll share what we learned about neural collapse and their rotation, how our experiment connect to generation, and the biggest open question we uncovered. So let us move forward. This is the SG task that I have done and all the requirements that were there. Just install the basic setup, then deal with the CIFAR data sets, then go on for the ResNet 18, and then for the layer rotation. We have what we'll discuss is the neural collapse, which is almost here. You can see 4.2 is also been done, so neural collapse is there. Like, neural collapse is geometry that often emerges late in training. Three signatures are key. The first is the NC1 within class variance collapses. Cluster get tighter relative to total variance. The second one is the ETF like alignment, which in the class means become roughly equiangular on a hypersphere. We check this with the off diagonal cosine mean variance among class means. The third one is the NC4, nearest class center classifier of penultimate feature matches the trained linear head. We measured all the three NC1, ETF epoxy, NCC versus linear head accuracy, and they are displayed here. I think you can see that. Those are all the plots that were there. And moving forward, I have the thing that is there. So I'll discussing what is the layer rotation. So let us move forward and let us discuss the what is layer rotation. So as you can see, there is a in which the layer rotation tracks how far each layer weights move from initialization, measured as cosine distance to init. Prior works shows that larger, more uniform rotation across layers often correlates with better test accuracy. We reproduce this with three optimizers: HGD, Adams, and a simplified Leica style controller that equalizes per layer rotation steps. And moving forward, we have the reproduction accuracy that we will be discussing. As you can see, here are the reproduction results, like the test accuracy, the curves. As you can see, like in the middle, the mean cosine distance to init and the final per layer rotation. Two patterns stand out. One runs that reached higher, steadier rotation also achieved better test accuracy, mirroring the original paper. The Leica start run produced a more even per layer rotation profile and a modest accuracy left over vanilla SGD with the same schedule. Where our absolute numbers differ from the paper, it's expected. We used a compact ResNet 18, a simplified controller, and a cipher setting. The trends matched rotation is a strong indicator of generalization. Moving forward, discussing about the methods. So some of the methods are here. As you can see, to go beyond rotation control, we tested a different out to generation, which is flat minima plus vicinal risk. Our pipeline uses SAM for flatness, mix-up and auto augmentation for invariance, label smoothing, and optional EMA. This is meaningful different from Leica. Instead of equalizing rotation, we optimize how low loss is in neighborhood and smoother decision boundaries. Moving forward, we have the matrices and the NC overtraining, which we have here. So now the results, the first, as you can see, the first accuracy in F1 improves over training. AOC shows similar progress. So secondly, the NC1 decreases steadily, evidence of within class variant mobility collapse. Third, the NCC accuracy converges to the linear head, and a hallmark of neural collapse. Together, these show that flat minima training and mix-up not only generalizes well but also accelerates stabilizes collapse relative to plain SGD. So, what can be the key takeaways for this is that summing up, rotation correlates with generalization. Equalizing its help independently, the SAM plus mix-up route gives strong generalization and clean collapse behavior. Both use a rotation lens and a flatness lens are valuable and complementary. So, moving forward, we have the research gaps as well that is discussed above. Let me see. Yep, as you can see. So, the four gaps that stands out is correlation versus causation. Rotation tracks accuracy, but enforcing a rotation profile doesn't always improve generalization under strong argumentation. 2x2 grid with or without Leica, which is in collaboration with or without SAM, separate effects of rotation and flatness. Robustness of NC, like which collapse is clean or on balance data under class imbalance and label noise. ETF structure degrades and NCC is not equal to linear. The control imbalance noise in addition to the de-weighting of robust losses to preserve NC. The architectural bias like L2 normalization, penultimate features can make cosine geometry look too good. Ablate normalize which versus the unnormalized heads and measure NC1 and NCC changes. The scaling and dynamics, how do these findings transfer to a deeper nets and larger dataset? Cipher 100 and tiny ImageNet track NC early versus late and test if each NC can guide early stopping or LR schedules. So these were all the things that were there. I have the proposed accuracy for the JSON model, which is almost here, as you can see, and all the JSON files of SGD, Adam and Leica is saved. So thanks for listening, and the code and logs are in the repo. Happy to take any questions.